This is an instructional video on raising exponents. So just as we were multiplying exponents and dividing exponents, the same basic properties still apply when we're raising exponents. The first thing to remember is that you must keep the base number. It has to stay the same. When you're actually solving the problem, there are two different methods you can use. The first method is to write it out the long way, which I will show you how to do. The shortcut method is to multiply the exponents. Again, keeping that base number the same. It's important to note that when you have a coefficient, you have to distribute the exponent to that coefficient number. So for our first problem, we're going to do 7 squared raised to the third power. So if we were to break that down, I would do 7 squared 3 times because my exponent outside is a 3. I can then break it down and do 7 times 7 for each piece because the second exponent is a 2. And I can count them up. 1, 2, 3, 4, 5, 6. My answer would be 7, keeping that base number the same, with the exponent 6. If we wanted to use the shortcut method, which was multiplying the exponents, we would multiply the two together. 2 times 3, which is 6. We keep the base number 7 the same, with our new exponent 6. This process also works with variables as the base number. For example, m to the third raised to the 5th power. If we were to write it out long ways, I would write m to the third 5 times, because that's my outside exponent. I can then break it apart and write m 3 times, because that's my second exponent. We count them all up. And we keep the base number the same, m, with our new exponent, 15. The same shortcut method still applies. You can simply multiply the two exponents together. 3 times 5 is 15. Keep your base number m the same. M to the 15th. Now for an example with a coefficient, 2x to the 4th raised to the 3rd power. 2 is the coefficient, x is the base number, 4 and 3 are our exponents. So we can write it out long ways. I write the parentheses part, 2x to the 4th. I write it 3 times because that's my outside exponent. We can break it down, and I can write x 4 times because that's my second exponent. The exponent only goes with the base number. Notice I'm not writing 2 4 times in each category. Count up my x's, my base numbers. Keeping that base number x the same, we get x to the 12th. And for 2's, I have 2 times 2, which is 4. 4 times 2, which is 8. 2 times 2 times 2. 8x to the 12th. Again, the shortcut method can still apply. We multiply the exponents. And that note I gave you told you to distribute your exponent to the coefficient. And so we would get 2 to the third power x to the 12th. Remember, we're multiplying those exponents. 4 times 3 is 12. That's where that comes from. We put the 3 with the 2. 2 to the third power means 2 times 2 times 2, which we just solved to equal 8. 8x to the 12th. Number 4, we have this problem, 4 to the third raised to the second power, and we are going to raise all of that to the second power. Start with the top exponent, it's a 2, so we write everything inside 2 times. We've gotten rid of the outside 2. The second 2 is outside the parentheses, so again, we're going to write 4 to the third 2 times. And we're going to break down 4 to the third. We write the base number 4 3 times. Count up our base numbers. Keeping the base number 4 the same, we end up with 4 to the 12th power. Now the exponents can also be multiplied using that shortcut method. We multiply all of the exponents together. 3 times 2 times 2. We know that 3 times 2 is 6. 6 times 2 is going to give us 12. Keeping the base number 4 the same, we still end up with the same answer, 4 to the 12th power. Going back to more simpler problems, we have 4 to the 8th power raised to the 2nd power. Again, you can write it out long ways. My outside exponent is a 2, so I write 4 to the 8th 2 times. My exponent now is an 8, so I have to write 4 8 times. We add those all up, and we end up with 16. Keeping the base number the same, 4 to the 16th power. If you decided to use the shortcut, you can multiply those exponents together, 8 times 2, which is 16. Keep your base number the same, and you end up with 4 to the 16th for both answers. Number 6, we're going to do 9 to the 4th raised to the 6th power. Since the outside exponent is a 6, we have to write 9 to the 4th 6 times. Now that the exponent is just a 4, we can go ahead and write 9 4 times. We add them all together, we count them all up, and we end up with 24 9s. Keeping the base number the same, our final answer is 9 to the 24th power. These are the types of problems where the shortcut method comes in handy because nobody wants to have to write that out 24 times. We simply multiply the exponents. 6 times 4 is 24. Keep the base number the same, 9 to the 24th power. You still get the same answer even with your shortcut method. For this problem, we're going to do another coefficient, 5x to the 3rd raised to the 5th. Writing it out long ways, my exponent is a 5, so I have to write the inside portion 5 times, 5x to the 3rd, 5 times. We then break it down again, and I write x to the 3rd 3 times. We can count up the x's, because that is my base number. And so part of our answer is going to be x to the 15th. We can also count up the 5s. There's 1, 2, 3, 4, 5 of them. And so it would be 5 to the 5th power. Again, the shortcut method of multiplying the exponents does still apply. Remember, we multiply the exponents together. You distribute the exponent to the coefficient. So 5 to the 5th power, I give that exponent 5 to the coefficient 5. We multiply the exponents 3 times 5 to get 15. Keep my base number x the same, my exponent 15. Last problem. We're going to do 11 squared a to the 6th raised to the 3rd power. If we decide to write it out long ways, I have to break it apart 3 times because that's my outside exponent. When we break it apart again, we have 11 twice because it's 11 squared, and I have a 6 times. And we do that for each one. 11 squared, so 2 11s, a 6 times. (11 squared, a 6 times). We can count all of the a's. That's our base number. And we keep it the same, a to the 18th power. Then we can count up all of the 11s. 1, 2, 3, 4, 5, 6. 11 to the 6th power. Just as with all the other problems, the shortcut method does still apply. We have to multiply both exponents, not just the 6 times 3 that we're used to doing. That's going to give us a to the 18th. But when we give the 3 exponent to the coefficient 11, it already has an exponent. So we have to multiply that one as well. 2 times 3 is going to give us 6. 11 to the 6th power.